Welcome to Asset Online Lectures. Myself, Bensi Wilson, Assistant Professor, Department of Information Technology. In this lecture, we are going to discuss some of the topics in Module 1 from the subject Software Architecture and Design Pattern IT301 for Semester 5. The main contents that we are going to discuss in this lecture are software, what is software engineering, and what are the different features and criteria of a software process. What is a software? A software is a set of instructions that, when executed, provide desired features, functions, and performance. A software is a data structure. It also enables the program to adequately manipulate the information. And a software is a documentation that describes the operation and use of the programs. Next, let's see the characteristics of a software. A software is developed or engineered. It is not manufactured in the classical sense. Next, the software doesn't wear out, but it does deteriorate. And the next point is, most software continues to be custom built. That is, a software component should be designed and implemented so that it can be reused in many different programs. Here, this figure shows the curves for wear versus deterioration. Software is not susceptible to the environmental maladies that cause hardware to wear out. In theory, the failure rate curve for software should take the form of the idealized curve which is shown in this figure. Undiscovered defects will cause high failure rates early in the life of a program. However, these can be corrected and the curve flattens as shown in the figure. Software applications. Next we will see the different software application domains. First one is the system software. It's a collection of programs written to service other programs. For instance, compilers, editors, and file management utilities are some of the system software applications. Second one is the application software. They are standalone programs that solve a specific business need applications in this area process business or technical data in a way that facilitates business operation or management. Some of the application softwares are Microsoft Word, Paint, etc. Third one is the engineering or scientific software. It's a broad array of number crunching programs that ranges from astronomy to the very complex engineering solutions. Fourth one is the embedded software. It resides within a product or system and is used to implement and control features for the end users and for the system itself. Fifth one is the product line software. They're designed to provide a specific capability for use by many different customers. For example, the inventory control products. Sixth one is the web apps or web mobile application. This network-centric software category spans a wide array of applications and encompasses the browser-based apps. The seventh one is the artificial intelligence software, AI software. Make use of non-numerical algorithms to solve complex problems that are not amenable to computation or straightforward analysis. Next is the legacy software. We will see the explanation of legacy software in the next slide. Legacy software. Legacy software systems were developed decades ago and have been continually modified to meet changes in business. So, why must a legacy software change? The main reasons are the software must be adapted to the new environment, the software must be enhanced to implement new requirements, The software must be extended to make it interoperable to all the databases or systems, and the software must be re-architected to work within a new network environment. Next topic is the software engineering. So what is software engineering? The software engineering is the establishment and use of sound engineering principles in order to obtain an economical software that is reliable and works efficiently on real machines. A software engineering is a layer technology. Here we can see different layers of a software engineering. The bedrock that supports the software engineering is a quality corpus, which is the base layer. Next layer is the process model or the process layer. It defines a framework that must be established for effective delivery of the software engineering technology. The third layer is the methods layer. Software engineering methods provide the technical how-tos for building software. The method encompasses a broad array of tasks that include communication, requirement, analysis, design modeling, testing, and support. And the topmost layer is the tools. Software engineering tools provide automated or semi-automated support for the process and the methods. The software process. A process is a collection of activities, actions, and tasks that are performed when some work product is to be created. So this figure shows a process framework. A process framework establishes the foundation for a complete software engineering process by identifying a small number of framework activities. And these framework activities is a set of umbrella activities that are applicable across the entire software process. We will see the further details of process framework in the coming slides. A generic process framework for software engineering encompasses 5 activities mainly. First one is a communication, next is a planning, third one is a modeling, fourth is a construction, and fifth one is a deployment. In modeling, we have a requirement analysis as well as the design phase. The construction, the main areas are the code generation as well as testing. Umbrella activities. Umbrella activities are applied throughout a software project and help a software team manage and control the progress, quality, change, and risk. The typical umbrella activities are software project management, formal technical reviews, software quality assurance, software configuration management, work product preparation and production, reusability management, measurement, and risk management. The essence of practice. The essence of software engineering practices are: first one is understand the problem, that is the communication and analysis phase. Second one is plan the solution, which includes the modeling and software design phase. Third one is the carry out the plan, which includes the generation of code. And the final one is examining the result, which includes the testing and the quality assurance phase. First one is understand the problem. So what are the different criteria or features that we have to consider in understanding a problem? So first one is, who are the stakeholders? Okay, that is, who is benefiting from getting a solution from the problem. Then second one is, what data, functions and features are required to properly solve this problem. Third one is, can we compartmentalize this problem? That is, can we represent the bigger problem into smaller ones? And the final one is, can the problem be represented graphically, and can we use any analysis model to create it? Plan the solution. The features that we have to consider in planning a solution. First one is whether any similar problems was solved before, or is there any patterns that are recognizable in a potential solution. Second one is whether a similar problem being solved, or if so, are elements of the solution reusable. The third one is can subproblems be defined? If so, are solutions readily apparent or clear for the subproblems? And the fourth one is can you represent a solution in an effective implementation manner? Or can design model be created? Carry out the plan. In carry out the plan, what are the features that we have to consider? First one is, does the solution conform to the plan? A source code traceable to the design model. Second one is each component part of the solution is provably correct or not? Has the design and code been reviewed, or better, have correctness proofs been applied to algorithm? Next is examine the result. So what are the criteria we have to consider here? That is it possible to test each component part of the solution? The second one is, does the solution produce results that conforms to the data, functions and features that are required? A generic process model. The software process is represented schematically in the given figure. Referring to this figure, each framework activity is populated by a set of software engineering actions. Each software engineering action is defined by a task set that identifies the work tasks that are to be completed, the work products that will be produced, the quality assurance points that will be required, and the milestones that will be used to indicate the progress. Process flow. One important aspect of the software process is the process flow, which describes how the framework activities and the actions that occur within each framework activity are organized with respect to the sequence, and it is illustrated in the figure given here. The first one is a linear process flow. A linear process flow executes each of the 5 activities in sequence, beginning from communication and ending with deployment. Second one is the iterative process flow, which repeats one or more of the activities before proceeding to the next. The next one is the evolutionary process flow, which executes the activities in a circular manner. And the final one is a parallel process flow, which executes one or more activities in parallel with other activities. In this lecture, we have seen what is a software, the features of software engineering, and about the software process. Thank you.